Yeah, this is where ecology meets some actual math. Now, don't worry, it's not hard math. And in fact, it's the kind of math that we're going to use technology to do for us mostly. In fact, I don't think I'm exaggerating when I say that it's going to change your life. The technology I'm going to show you is going to make your life better. Or at least, I mean, I can tell you it's made my life way better. Like saved me days of work. Anyway, we'll get there. Basically, population ecology has to do with all the factors that can cause a population to grow or shrink. So let's think about population growth. What if you want to know if a population is growing or not? What numbers would you want to know about that population? Let's call it a population of rabbits in a meadow ecosystem. What do you want to know about those rabbits to know if their population is growing or shrinking or just holding steady? What do you need to know about the rabbits, Tyler?
I want to know about the food that they eat and like know if there's plentiful or if there's not enough.
Okay, so then underneath that, what is that going to do if there's more food or less food?
The birth rate and death rate probably.
You want to know all that stuff like is there enough food, is there enough space, are there predators? What that's going to affect is the death rate. And so you want to know the death rate, but you also want to know what's the basic birth rate of rabbits. So births and deaths. High. The basic birth rate of rabbits is high, by the way. Super important. That seems like all there is, but it's not. There are two other things that can happen in a population to change its size, to make it grow or shrink. Birth rate can change, death rate can change. What else? Tyler? That's going to affect the death rate. Okay, to get this one, let's just think about Springboro. Let's think about the population of humans in Springboro. What's it doing? Growing or shrinking? Growing, yeah. Is it because the birth rate has gone up? It's not because the birth rate has gone up. It's because the death rate has gone down? No. Jack? People are moving here. What's a good sciencey word for that? Migration just means movement, but you have exactly the right word root. What prefix do we put with it for moving in? Immigration. Immigration is individuals moving in, and it's not just humans that do that. Sometimes a bunny will get lost and find its way to a new population of bunnies. What's the opposite? What do we call moving out? With an E instead of an I. Perfect. Emigration is individuals leaving. That's about all there is. They can be born, they can die, they can leave, or they can join. So we can set up a basic equation. And the basic equation, or I guess inequality, says if births, whatever that number is, plus immigration is greater than deaths plus emigration, that population is growing. Let's do some simple population growth math. Simple, I promise. I promise. Once we get past simple, we'll start using technology. All right, you don't have to write this part down, but we are going to track the simplest kind of population on Earth. What is the simplest living thing on Earth? Somebody said boys last period. What's the simplest living thing? What do you think, Dawson?
No idea.
Okay, fair enough. Do we want to just give it a guess? Got it in one. Yeah, usually we have to go through plants. No, they're very complex. Worms, no, they're pretty complicated too. Bacteria are made of one cell. They don't even have a nucleus in that cell. They're the simplest organisms on Earth. So they're great for a population study. How do bacteria reproduce? Asexually, what does that mean? What does it look like? Chris? They literally, like, here's the cell. They copy their DNA inside the cell, and then, good sound effect. They split. Yeah. So, take a average bacterium. Don't write this. Under ideal conditions, nice big petri dish, we're growing the bacterium, and we start with 1. They are going to do that division thing every 20 minutes. Okay? You got it? Picture that? What I want to know is how many are there? Starting with 1, how many are there after 2 hours? All they're doing is dividing. I mean, you know how many minutes are in an hour, right? All right, get me a number. Keep in mind, though, you're not just adding 1. You're not just adding 1. Are you okay, Dawson? I'm sorry, did I rattle you? You're not just adding 1 every 20 minutes. What are you doing every 20 minutes? Yeah, because it's not just this one divides and then the next one divides. Like, they all divide every 20 minutes. So that 1 divides into 2, but then those 2, they both divide in the next 20 minutes. So you are multiplying by 2 every 20 minutes. Go.
I've already got it.
Good, keep it. Let's see if everybody else can get there. Here's where we learn that there are 2 kinds of people. There are people who will use numbers for this, and there are people who will draw the little bacteria, which is awesome, but is going to get old very quickly. I advise you to switch to numbers if you are a circle drawer right now. Probably the 2-column method is best here, where we start at time 0 with 1 bacterium. And then we go, okay, after 20 minutes, we have 2, and so on. That's the way I would advise doing it. Just to make sure you don't get confused. I don't know what they do to the water. All right, do we have a number? Hey, do you have a number? Jack, what's the number?
128.
Oh, too far. Braxton?
64.
64, good, because we only got to go 40, and then that's 1 hour, 120, 140, 2 hours. We go 4, 8, 16, 32, 64. Everybody agree? Good, because that was just the warm-up. I want to know how many there are after 6 hours. Use the same method. It'll work fine. You might, I can get about halfway through this in my head. You might want a calculator. Perfectly fine to use one. Hopefully you have numbers already because you understand how exponents work. And that you're really just taking 2, because this is a doubling time, to whatever power is the number of 20-minute periods this is. All right. Do we all have a number? Are we getting close?
Yeah.
If you're getting to numbers where you're like, it cannot be that big, then you are probably doing it right. Because, all right, we got to take it out. So we stopped at 2 hours. So 220, 240, 3 hours, 320, 340, 4 hours, 420, 440, 5 hours, 520, 540, 6 hours. Yes?
I think I got it.
Okay, hang on to it. Let's see if we agree. And you guys got to help me because I always screw this up once I get into the high numbers. We go from 64 to 128 and 240. It's 256, then 512. This is all computer memory stuff, or that one game. What's the game called? Yeah, 2048. So 1024, 2048, 4096, 8192, 16,300 what? This is where I lose it. 84, 32,768, 64,000. 65,000. Told you. 536, 131, 072, and finally 262,144. That is more than 250,000 bacteria. We started with 1 6 hours ago. Holy cow. How I get what?
44.
44?
I got
272 times 2 is 144.
well, I guess it doesn't.
I'm going to put my money on operator error, Jack.
I hit times 2 every single time.
Cool. Maybe it'll learn. Let's never do that again. Grab a device. Log in and get into Google Drive and make a new sheet. I'm about to save you so much work. I don't want to oversell this, but spreadsheets will change your life. I promise. Create a new spreadsheet and call it your last name and then population graphs. It's a new sheet. Call it your last name and population graphs. And then let's do that same thing. Let's go. Column A will be time in minutes. Column B, number of bacteria. And then we're going to say, here's time 0. Here's 20 minutes. And stop. We don't have to type anything else. 2 tricks you're going to learn today. First, this one's cool. The second one's like the life-changing one. Do you know how to select more than one cell? You just click in one and then drag to the other, and they both turn blue. Do that. Now, you see how there's a little square? And that your cursor turns into a plus when you drag over it? Do that. How many 20-minute periods is 3 hours? 6 hours, sorry, 6 hours. 18, good. So we're in column 3 already, or row 3 already, so we're going to go to 20. Just drag down to 20. And if you go too far, you can drag it back a couple. That's fine. Oops. If you don't go far enough, you can drag it down a few. It'll go further. I know, right? Ah! Don't do that. Because you did a label and then you did a 0.
Okay.
So it's 18 plus 2. And I guess I'll just leave it at 440. Okay, second column. We start with 1, right? So hit 1 and go to the cell below that and stop in that column. Now, this is slightly more complicated, so we are going to have to use a formula. Formulas in spreadsheets are about the most powerful thing you can do. Raise your hand if you've learned about formulas in spreadsheets at all. Oh, I'm so excited. I get to be the one. Okay, the universal spreadsheet symbol for, hey, I'm about to do a formula is the equal sign. So hit the equal sign. Now, what you want is for that cell to take the cell above it and multiply it by 2. Agreed? So click on the cell above it one time. And magically B2, which is the coordinates of that cell, will appear. And now you just want to say that times 2. But spreadsheets don't like the X. They don't use that for multiplication. So first thing you have to remember is that equals means formula. The second thing is asterisk, which is shift 8, is multiplying. So it's that cell times 2. And then you hit enter. And it does that, which doesn't seem like a big deal, except what you just did was created a formula that any cell can use to multiply the cell above it by 2. So all we have to do now, don't select both cells, just select the one with the formula. And do the same thing. And go down to 360. That is the beginning of a technique that will absolutely save you days of work if you can learn how to use it. Spreadsheets are maybe the best tool I've ever found in my life to help me do math when I'm not good at math. Okay, so now let's graph it. That's another thing you hate doing by hand, right? Spreadsheets to the rescue. Select your entire 2 columns of data. We've done this before, right? With the corn. Turn the whole 2 columns blue. Gavin, you all right? Need help?
Yeah.
Okay. Turn the whole 2 columns blue, and then you remember how to make a graph, right? Yeah, so to do a graph, remember they don't call it a graph, they call it a chart. You just hit insert, chart. It might even give us what we want. Ooh, my stuff is slow today. Did I miss it?
Maybe a little lower.
Oh, there it is. Yikes. Oh, because I'm so 100%. Yep, automatically should go to a line chart. If it doesn't, if it starts out as a bar chart or something, you just change it to a line chart. And does that look about right? Right? That's the story, is that we started increasing very slowly for a while, but once we got in the 200-some minute range, things really shot up fast. Questions? Okay, we'll come back to spreadsheets. We'll come back to what kind of, actually, you know what, let's get that in our notes. That kind of growth, anybody know what it's called? Very good. Your math teacher did you right. That kind of growth is called exponential growth. Go ahead and just draw a version of that in your notes. And it turns out that exponential growth is the kind of growth that any living population will undergo if you give them all the stuff they need. We'll talk more about that, and then we'll talk about a different kind of growth on Monday. Any questions at this point?